All right, so we want to fill out our Scatterplot learning card. So this is a bunch of information on Scatterplots. So we're going to start off here in the middle and talk about the tips for plotting your Scatterplot. Well, the number one thing that we want to talk about to begin with is that the explanatory variable is always going to be on the x-axis. It's very important to remember. So if we're looking at the age of people and their driving speed, maybe this is their average driving speed, what we can see is that on the x-axis, age would be our explanatory variable. Now, the vertical axis is the response variable. But when we put things on our x-axis or our vertical axis, the other thing that we want to remember is that we want to label the axes. And not only do we want to label the axis properly, but we also want to scale with our tick marks properly. So what I like to do is put my minimum value on first, put my maximum value on last or on second, and then start putting tick marks in the appropriate places. If we don't scale properly, then what will happen is we will end up squeezing a bunch of tick marks into the end of this axis, and we don't want to do that. So don't just cram all of your data into a corner. Okay, nobody puts data into a corner. So if I were to create a dot plot and I don't scale properly, I may end up putting a bunch of dots in this one corner, but I have all of this other space here and here. Okay, scale properly before you, and so in other words, plan ahead before you start putting your dots on your dot plot. Now, another thing that we need to learn about our scatter plots, I said dot plot, I should have said scatter plot. But another thing that we need to remember about scatter plots is that a scatter plot will show correlation. A scatter plot will show correlation, but it will not show cause and effect. Just because something is there appears to be a strong correlation between two things, that does not show cause and effect. Scatterplot can only show correlation or association, but not cause and effect. So we need to keep that in mind. So let's go ahead and come up here to our scatterplot, and we kind of know this. It's not always the case, but as age increases, driving speed usually decreases. Older people tend to drive slower than younger people. So our scatter plot may look something like this, and it's going to have a negative slope to it as we look at this scatter plot. Now, that's not always going to be the case, but in general, as people age, they tend to drive slower. So going back to this cause and effect, is age the only thing that causes people to drive slower? Well, of course not. There are other things that come up. It might be a person's eyesight may get worse, and that may cause them, or may be part of the effect of making them drive slower. They may have slower reaction time, so they want to drive slower to be safer. They may just have more wisdom in their life, and they realize that driving fast is not the safest thing to do. So is there a correlation between age and driving speed? As age increases, does the driving speed decrease? Well, yes, but that's not cause and effect. So a scatter plot can just show correlation. Another thing to keep in mind when it comes to scatter plots is that we must have two quantitative variables. Scatter plots are created with quantitative data, not categorical or qualitative data. It has to be quantitative data. Down here in the middle, we're going to go ahead and take a look at how to make a scatter plot on our calculator. So in order to do that, the first thing that we do is hit second, and then we go to stat plot, which is the y equals button, and then we put all of our information in. Now we got to remember that all of our data needs to be in L1 and L2, or in a couple of different lists. It doesn't have to be in L1 and L2, but it has to be in those lists. And then to see the scatter plot, we want to hit zoom stat. And zoom stat is at zoom number 9. Now, sometimes when you hit zoom number 9, you may get an error. If you get an error, it's probably because you have too many values in one of your lists. But if you go back and look at your lists and your lists match up perfectly, then what that means is you probably have an equation in your y equals list or your y equals menu, which is not matching up and allowing your calculator to show the scatter plot that you're looking for. So just go turn that off or delete that equation, and then you should be able to see your scatter plot. Now over here on the left, we've got D, F, and S. When we are analyzing a scatter plot, there are three things that we should talk about, and those are direction, form, and strength. We talk about the direction of a scatter plot, we really only need to say two things, positive or negative. So in this scatter plot up here, it's going to be negative because it has a negative slope to it. So positive or negative. Then we get to form. And when we talk about form, there are two types of form. We could say linear or nonlinear. Sometimes people will say curved as well, but linear or nonlinear are the two that are the most common. Finally, we get to strength, and strength can be described basically in three different ways. And we determine the strength of a scatter plot can be determined by its R value or the correlation coefficient. The three different ways to describe the strength of a scatter plot are strong, moderate, and weak. You really don't need to get more descriptive than that. Some people will say very strong or very weak, but strong, moderate, or weak is good enough. Now we want to come over here and we want to look at these 6 scatter plots. So I'm going to give a correlation coefficient R for each one of these, and then based off of the picture itself, the scatter plot and the correlation coefficient, I'm going to give the direction, the form, and the strength for each one. All right, so this first one has an R value, a correlation coefficient of 0.9. Well, by looking at the scatter plot itself, I can tell that this is a positive direction. It looks like a pretty straight line. It's not curved, so I'm going to call this linear. And a correlation of 0.9 is strong. That is a strong, positive, linear association between these two variables, whatever they may be. Let's take a look at the next one. So in this one, we have a correlation of 0.7. But by looking at the scatter plot first, I can tell that there definitely is a positive direction. It is pretty linear. It's all in a line, so I'm going to say that's linear. And then based off of the correlation coefficient of 0.7, I would say that's a moderate strength. Okay, 0.9 is strong, 0.7 we would say moderate. All right, let's take a look at this one down here in the middle on the left. I look at this scatter plot, I don't see any kind of pattern at all. There are just dots all over the place. So the correlation coefficient here is probably going to be 0 or very, very close to 0. So there is no direction. You can't tell if it's positive or negative, so I just say none. You really can't tell if it's the form either. It's definitely not linear, and it's definitely not curved. So I'm just going to say there's no form to it at all. And then finally, the strength, since there's no direction and since there's no form, there really is it's not applicable to put any kind of strength on this at all. So there is no strength at all on that one. I wouldn't even call it weak. So because there's no direction and no form. All right, let's look at the next one. On this one, when I look at the scatter plot, I can definitely see that there is a negative association. As the x variable increases, the y variable is decreasing. So that would be negative. But I can definitely see a curve here. So because of that curve, I would say that it is nonlinear or curved. There's definitely not a linear relationship there. Now, the last thing that I would look at is the strength. And usually when we look at the strength, we want to look at the correlation coefficient. But this correlation coefficient R is a linear correlation coefficient. So if I have a distribution, or I shouldn't say distribution, if I have a scatter plot that is nonlinear, if this scatter plot is nonlinear, then I should not be finding the correlation coefficient for it. I should not be finding this linear correlation coefficient. But so that's why up here we say non-applicable. But we can definitely tell that it is strong. There is definitely a strong relationship going on here, a strong association going on here. All right, let's look at the last two. So in the last one here, we definitely can tell that if we look at the scatter plot, it's going to have a negative association. It is pretty linear. I don't see any kind of curve there, so I'm going to call it linear for the form. And then the strength is going to be based off of the correlation coefficient. So let's see what that is. As we can see, we have a correlation coefficient of negative 0.8. So the negative on the correlation coefficient just confirms that it is a negative direction. It is linear, and negative 0.8 is pretty strong. So I'm going to say strong association between these two variables. And then we come to our very last one. So there's a few things that I can look at here. The first thing I can tell is that it is definitely negative. So this is going to have a negative direction. It looks pretty linear to me. So I'm going to say that it's linear. But then we come to the strength. Like, I don't see any curve to this. This one little dot is kind of out here by itself, but that's not making any curve here. So it's still linear. And what is the correlation coefficient? Well, the correlation coefficient for this particular scatter plot, we're going to say is negative 0.5. So this correlation is negative 0.5. If you get down into the 0.5s, you're getting closer to 0. And in that case, I would say that this is pretty weak. So there you have it. There's your learning card information for scatter plots. There's a lot of information on here, but all of it is important. So hopefully you've learned a few things along the way, and I hope you have fun in your stats class.